All right, so today we're going to do section 1.8, other types of inequalities. And this basically just means nonlinear inequalities. What about inequalities where we can't just isolate the x? How do we solve them? And so the idea is going to come from the fact, it's going to come from the idea of comparing to zero. So for instance, let's just say I asked, what is a positive times, I can't write it. A positive times a positive times a negative times a negative times a positive. So think about what that product would be. Would it be positive or would it be negative? And if you're thinking positive, you would be correct. That is right. And it's all about the negatives. It's because there's an even number of negatives. The positives don't really matter. It's all about the negatives. The negatives will determine the sign. So if I have a negative times... Oh, this is so hard to write. A negative times a negative times a negative times a negative times a positive. What's the answer this time? And we have 1, 2, 3, 4, 5 negatives. There's an odd number of negatives, so the answer is going to be negative. And I could even go crazy, and I could ask, what is a positive times a negative times a negative divided by a negative times a negative times a negative times a negative? So think about that. And if you're thinking positive, you would be correct. Again, division follows the same rule as multiplication. So we have 1, 2, 3, 4, 5, 6 negatives altogether. It's still an even number. So the answer is positive. So the idea of what we're going to do today is all about this. Knowing that when you multiply or divide an even number of negatives, your answer is positive. And if you multiply or divide an odd number of negatives, your answer is negative. All right, so let's take a look at this example. Let's look at x minus 3, x plus 2, 1 minus x is greater than 0. And let's see how to do this. Now remember, it's all going to be based on this idea that we were talking about above. So it's all about finding when we were multiplying a bunch of things together. So when is this product going to be positive and when is it going to be negative? Which means we can compare it to 0 really nicely. We're looking for when it's greater than 0, that would be positive. If it was less than 0, we'd be looking for when it's negative. So the key is we want that side to equal 0. So the first thing you should always do, if it's not already done, is set one side equal to 0. That way you can compare to 0 and look at positive or negative. So then the next step is to find the critical numbers. And the critical numbers are where the expression is 0 or undefined. So looking at the left side, looking at this expression right here, it's never going to be undefined, so we don't have to worry about that. If we had fractions, we should worry about that. But we're okay here. So it's really going to be about where it equals 0. And you can see that it's super easy to find the critical numbers because it's factored. So in general, to find the critical numbers, you factor it and set each factor equal to 0. So if we set each factor equal to 0, we'll be able to easily find the critical numbers. We have x equals 3, x equals negative 2, and x equals 1 as our critical numbers. And then the last step is to make a sign chart. Actually, I shouldn't say the last step, but because the last step is to write your final answer. So make a sign chart. Now, I'm going to say this because I know some people have seen this before, and there's lots of different ways to format a sign chart. So if you have a way that you're comfortable with already and it looks different from the way I'm going to do it, you don't have to do it the way I'm going to do it. I find this way kind of the most straightforward way of looking at a sign chart, but it's kind of a personal preference. So if you have something that works for you, by all means, keep doing it. I'm totally fine with that. As long as it's mathematically valid, I don't have a problem. But let me show you what a sign chart is. It's what it sounds like. it's a chart with signs. It's going to be a chart with a bunch of positive and negative signs in it. So the way to format the sign chart, or the way that I format it is, so once I've factored the expression to find those critical numbers, I take each one of those factors and list them off to the side. So I have x minus 3, x plus 2, and 1 minus x. And I'm going to leave a gap and then put a number line, because I will fill in something in that gap in there. And then on my number line, I'm going to put all my critical numbers. And you don't have to worry about having a scale that's accurate. The only thing that matters is you put the numbers in order from smallest to biggest. So make sure that. But it doesn't matter if you have them spaced appropriately on the number line. And then I'm going to draw these little dotted lines here, because each one of those critical numbers divides the number line into these intervals. So we have 4 intervals that we're going to worry about. And in each one of these intervals, this original expression up here is always positive or always negative. And we're going to be able to find that pretty easily. So the way you do that is look at one factor at a time. As long as you have factored it correctly and you have found your critical numbers correctly, then each one of these factors is either always positive or always negative in each interval. That's the nice thing about doing this. So let's look at the first one, x minus 3. So let's just look at, you can do this one of two, actually you can do it one of 3 ways. One way is just think about it conceptually. So if I'm here and I'm any number less than negative 2, well, I'm always negative, and a negative minus a positive number, so a negative minus 3, that's still gonna be negative. Another way to think about it is you could just take an actual number. Pick a number in this interval, like negative 3. Negative 3 minus 3 is negative. I'll show you the third way in a second. So let's keep doing that. In this interval here, if I'm between negative 2 and 1, well, let's see here. I don't have enough positives to overtake this minus 3. So it's going to be negative. Or I could pick an actual number, like 0. 0 is in here. 0 minus 3 is negative. If I look at this next interval between 1 and 3, again, I don't have quite enough positives to overtake that negative. So a positive minus 3, as long as that positive number is less than 3, it's still going to be negative. But I can also just take a number like 2. 2 is in this interval. And 2 minus 3 is negative. And then finally, when I get here, now I have more than 3 positives, and so if I subtract 3, I'm still going to have positives left. Or I can think of it as, pick a number here in this interval like 4, and 4 minus 3 is a positive. So 2 ways you can fill these signs out is you can think conceptually in each interval, or you can actually pick a number in each interval and plug it in. But another way you can do it, and this is probably the fastest way if you can get the hang of this, is think about this graph. If we had a graph of y equals x minus 3, so what would it look like? It'd be a line. It'd be a line with a positive slope. And it's going to cross the x-axis at its 0. So it's going to cross the x-axis at 3. So a line with a positive slope that crosses the x-axis at 3, it's going to start off below the x-axis, cross at 3, and then be above the x-axis. So it's going to start off here negative and then become positive. So it's negative and then finally became positive after it's 0. So like I said, that's definitely the fastest way to do it. Any one of those ways works. So let's look at the next one then. X plus 2. I'm going to do it I'm going to try to get you guys the hang of the faster way. So x plus 2, that's going to be a line again. Y equals x plus 2. It's a line with a positive slope. It's going to cross the x-axis at negative 2. So it's going to be negative, cross at negative 2, and become positive. So it's going to be negative and then become positive. And then the last one, 1 minus x, this is also a line, but this time it's got a negative slope. so it's going to go downhill, and it's going to cross the x-axis at 1, so it's going to start off positive and then go negative. So it's going to start off positive and then become negative. So now I have what's happening with each factor in each interval, and remember, we're multiplying these guys together, so I can look at this as a product of a negative times a negative times a positive. There's an even number of negatives, so it's positive right here. And remember how in the beginning when I said I set this thing up, I put my factors, I leave a gap and then put the number line? This is what I'm going to start filling that gap in, is with my final product, the sign of the final product. So here in this next interval we have an odd number of negatives, so the product's going to be negative. Then we're back to an even number of negatives, so it's going to be positive. And then we have an odd number of negatives, so it's going to be negative. And now I'm almost done. So now let's see. We are looking at, let's go back to the original problem now. We're looking at where this thing is greater than 0, not equal to 0. And remember, each one of these critical numbers made it equal to 0. So I want open circles on each one because I don't care about it being equal. And because I care about it being greater than 0, that's where the product is positive. And the product is positive right here in this interval and right here in this interval, because I found that my product was positive. And so now I have my answer in the sign chart. Now I just need to write it, and you can write it as an inequality or you can use interval notation, but that's your last step then, is to write the final answer. So let's do it. So the final answer is going to be in interval notation from negative infinity to negative 2, not including the negative 2, and then from 1 to 3, not including those those endpoints. Or in inequality notation, it's x is less than negative 2 or between 1 and 3. And there's your answer. So that's going to be the idea now. So again, in general, what you're going to want to do is make one side equal to 0, find the critical numbers, and to find the critical numbers, it's where it equals 0 or is undefined, so the easiest way is to factor. If it's not already factored, factor it. Make your sign chart, and then from your sign chart you can get this. And when you get the hang of the sign chart, it's actually pretty quick to do these problems. The key, again, to doing it quickly, though, is to think about, like, what would the graphs of each one of these factors look like? All right, let's try another one. Okay, so here's another one. Pretty similar to the one above. Actually, it's really similar. The only difference is we have a squared here on this factor. So we have this factor twice. So go ahead, see if you can look at the previous example. Try this one on your own, and we'll take a look at the solution together. So pause the video right now and give it a go. All right, so let's take a look at this one. So I've worked it out, and it's, like I said, it's very similar. The only difference was really the squared. So one side already equals 0. We're good there. It's already factored for us, so it's easy to find the critical numbers. So they're right here. And then I set up my sign chart. And the thing you want to remember is there are 2 of these factors. So make sure you account for both of them in your sign chart. You can either list them separately, or it's okay to list them together like this, like I did. And actually, it's going to be faster if you do it this way, and I'll show you why in a second. And then I set up my number line and put all my critical numbers on it. So to fill out the sign chart, remember, no matter what x is in here, it's going to be squared. So this is always positive. So I just went ahead and listed positive straight across and moved on. There will be a place when it's 0. It will be 0 at x equals 3, but remember, that's one of our dividing points of an interval, so we're not really saying what happens there anyway. In fact, by doing this, we're saying it equals 0. So it's okay that technically it's not really positive everywhere. There is one value of x that will make it equal 0, but we've already accounted for it by making it a critical number. So that's why it's faster to put this one together. instead of listing x minus 3 twice, it's going to be faster. Just put it squared and list it across. In fact, any factor that's always positive, you can actually technically leave out of the sign chart. Because remember, the signs in the final product are all based on how many negatives there are. The positives are irrelevant. So if you already know that a factor is always positive, you could even leave it out of the sign chart totally. Anyway, the next ones we already did above. X plus 2, remember, is a line with a positive slope crossing at -2. So positive slope starts negative and then becomes positive at -2. And then the line y equals 1 minus x has a negative slope. So it's going to start positive and then become negative at 1. So it's going to become start positive and become negative at 1. And then once we have that, just look for the number of negatives. An odd number of negatives here that we're multiplying, so the product is negative. Here we have no negatives, so the product's positive. We have an odd number of negatives again, and we have an odd number of negatives again. So going back to the original problem was greater than 0. That's what we cared about. We didn't want equal to 0, so that's why I put open circles here. But then greater than 0 means positive, so there's only one interval where it's positive. It's positive just right here, so there's our answer. All right, so let's just look at a couple more of these, and yeah, we have a few more examples together, but it's just going to be now going through this. So let's try another one. All right, so here's another one to try. Give this one a go on your own. There's really nothing different about this one, so give it a go, and then we'll come back together. All right, so here's the answer to this one. And really, this one was no different than the other ones above. I just wanted to show you another trick you can do, which can make the sign chart go just a little faster. So it wasn't fully factored, the original problem, so I did fully factor this quadratic and then found its zeros. So I found those critical numbers that way. But notice when I made my sign chart, I actually just listed the original quadratic up here. And the reason is because I also know what graphs of quadratics look like. This a equals 1, so I know it's a parabola that smiles, and it's going to cross the x-axis at its zeros. And since these two factors came from this quadratic, I know that these are its two zeros. So, and they're right here on the number line. So I know the parabola is going to go like this. It's going to start off positive, then become negative, and then become positive. So it's going to be positive here, then negative, and then positive. So positive, negative in between the zeros, and then back up positive. So it's another way that you can fill in the number or the sign chart just a smidge faster. But again, I could have done the same thing and listed these two factors separately. I would have gotten the same end result. It's all about the end result. So, but after that, the only other difference is here. This time it did equal 0, so I did want to make sure I shaded in the circles. And I was looking where it was less than 0. So this time I wanted to make sure to shade where it was negative. And then I wrote my answers. So, but other than that, it's the same kind of problem. All right, I have a few more examples. Each one's going to have a different little twist to it, and then we'll be done with the notes. But it's just this idea over and over and over again. All right, so take a look at this one. And if you want, go ahead and just try it right now. I'll stop a little bit and give like a few hints and then have you keep working in case you get stuck. But go ahead and try this one right now, and then we'll take a look together. Okay, so remember, one key step that you have to do is you have to make one side equal 0. And it didn't equal 0 right now, so I had to subtract 25 from both sides. So if you got stuck, that's the first step that you need to do. So now, see if you can go on. Okay, before we go further, remember another hint on this one is that it is a difference of squares in disguise. And we had some problems like this on our homework when we we're first doing factoring. Remember difference of squares, and I wrote it up here in the corner. Difference between two perfect squares, and that's exactly what we have. We have subtraction, and then we have x plus 2 squared, and 25 is 5 squared. So it's like our a is x plus 2, and our b is 5. So it's a minus b, a plus b, or x plus 2 minus 5, x plus 2 plus 5. Definitely the fastest way to factor this one. Okay, if you got stuck there, now keep going. All right, and here's the final answer. So there are a couple of things we could have done. One is just what I did here. So if you simplify each one of these factors, you get x minus 3x plus 7. And so that's easy enough to find the critical numbers. I made my sign chart. But another thing that I could have done when I made my sign chart is kind of what I did above. These are the zeros for this quadratic. Remember, this was actually a quadratic expression right up here. And I know if I was going to graph y equals this quadratic, it would be a parabola that smiles. So a parabola that smiles, it's going to start off positive, go negative, and then positive. I could have gotten these right here really quickly from that. But again, I could list the factors separately, so different ways you can do it. And then don't forget, always think about once you've made it equal to 0, once you've made one side equal to 0, look at what the sign looks like. It's a less than, so we want to shade negative. All right, let's take a look at another one. All right, so give this one a go. It's fairly straightforward. It's just not factored, so you're going to have to factor first. But otherwise, it's pretty much like the other ones we've done above. So try this one on your own. All right, and here's this one. Now, the only other thing that I really want to point out about this one, first of all, it was factoring by grouping. Here, let me actually do that. It was factoring by grouping, but also I got this quadratic. I could have factored this further, but remember, what I'm really trying to do is just find the critical numbers, and so I already know the critical numbers from this are going to be plus or minus 2. But you could factor it if you wanted to. And then notice when I put it on my sign chart, I just wrote it as a quadratic. It's a quadratic that's going to smile. So it's going to be positive, and then go negative, and then become positive. It's going to cross at negative 2 and positive 2, so it's going to be positive, go negative, and positive. So I filled in the sign chart quickly like that. But otherwise, there's your solution right there. All right, now the next example, we're actually going to work together. And then we have one more after that, and we're going to be done, I promise. Okay, so let's look at this one. So this one's a little different because it's got rational expressions in it. So that's why I want to do it together and just show you some ideas. I'll give you some things that we're going to do. So if you want to pause the video at certain points and try like the next step on your own. But hopefully everybody knows the first step, because the first step is the same. You got to make one side equal 0. So we'll just subtract the right-hand side from both sides and make the right-hand side equal 0. So the next thing you have to do to find the critical numbers, what you're actually going to want to do if you have something like this, like a rational expression, you're going to have to combine it into a single fraction. And so you're going to have to do the whole, since this is subtraction, we're going to have to do the whole find a LCD and combine them together. So if you want to go ahead and pause the video right now and just practice finding an LCD and combining those two together, definitely go ahead. Otherwise, we'll do it together. So remember, to find the LCD, you have to fully factor the denominators, but this one's friendly. The denominators are already factored, so it's going to be easy to spot the LCD then. It's just got to be x minus 6, x plus 2. It has to have each one of these denominators as a factor in it. And so that's going to be our smallest denominator that has each one of the original denominators as a factor. So then if we think of the first one, the first fraction is missing the x plus 2, so I'd have to multiply the top and the bottom by x plus 2. And then on the second fraction, the denominator here is missing the x minus 6, So I'd have to multiply the top and the bottom by x minus 6. And I was writing it this way because the next step would be to put them over the same denominator. So I'm just going to go ahead and write that right away. So now I've got that. And then what I have to do is just combine like terms in that numerator. So I'm going to go and distribute. Hopefully I'm not making any silly mistakes. Okay. And then 5x minus 3x is 2x. 10 plus 18 is 28. And then I can factor that numerator. I can factor out a 2. And so I have this. So now I've gone ahead and I made one side equal to 0, and I've combined the left side to a single fraction. From here, though, even though I've got a fraction, it's pretty similar to what I had before in the previous problems. I just have division in there, but remember, multiplication and division have the same rules. If you multiply or divide an even number of positives or negatives, the answer is positive. But if you multiply or divide an odd number of negatives, the answer is negative. It's all based on that still. So we can find our critical numbers, and we can just look at these. We don't have to set each one equal to 0. Our critical numbers are going to be x equals negative 14, 6, and negative 2. So then I set up my oh my god, just drew a blank. My sign chart. And I'm going to do it off on the side here. One thing I do want to point out, I have this constant of 2. That doesn't create a critical number. Remember, by definition, critical numbers are where it's going to equal 0 or be undefined. 2 is never equal to 0, and 2 is never undefined. So that 2 does not make a critical number. It does make a factor, though. So I can put that in my sign chart. And then x plus 14, and then x minus 6, and x plus 2. And let's see, negative 14 is the smallest, negative 2 and 6. So now when I go to fill in my sign chart, 2, well, that's just a positive number. It's always positive. So I'm going to put positive straight across in my sign chart. And then remember, I also said above that if a factor is ever always positive, you can either put the positives all the way across or just leave it off the sign chart in general, because it's really about the negatives that we care about. So I actually could have left the 2 off, but it's only because it's positive. Remember, if that had been a negative 2, I would have had to have kept that in there. Just want to make sure we're clear on that. All right, so then I'll just fill in the other stuff pretty quickly. X plus 4 is a line with a positive slope, starts off negative and becomes positive at negative 14. The next factor, x minus 6, also a line with a positive slope, starts negative and becomes positive at x equals 6. And then x plus 2 is also a line with a positive slope, so it's going to start off negative and then become positive at negative 2. So it looks like my signs are going to be like this. And then looking at, after I made one side equal to 0, I'm looking at greater than. Sometimes you end up flipping the sign. So that's why I always wait until you make one side equal 0. Don't look at the original. Look at this, in case you ever multiplied or divided both sides by negative or something. But I'm looking right here, so I want to shade where it's positive. Whoops. And we have this. And then I could write my answer. So in general, when you're doing rational inequalities, the idea is you still want to make one side equal to 0, but then combine this into a single fraction so that you can still think of it as only multiplying and dividing factors. You don't want to put subtraction in there because it's harder to know when it's going to be greater than 0. But if you're multiplying or dividing, much easier to determine when you're going to be positive or negative. Now, I want to change this problem slightly, because there's one extra thing you have to keep in mind with rational expressions. That's why I haven't written my final answer yet. What if I made this equal to, greater than or equal to 0? So then all of these were equal to 0. I have greater than or equal to 0 all the way down. Well, if we think about what we did above, you just shade in all the circles. Except, are we really going to want to shade in all the circles? Probably not if I'm asking the question. And the reason is, remember that we have some implicit restrictions here. We have x minus 6 and x plus 2 in the denominator. And the denominators, I don't care if it says equals 0 here, the denominators can never equal 0. It's going to make the whole thing undefined. So even though it has an equals to here, any factor from the denominator that gave you some critical numbers, you still don't want to shade those. So we're not going to shade the 6 and the negative 2, but we will shade the negative 14. So that ends up being the only difference with that equal to. So, but just very, very important point. Make sure that if you're dealing with a rational expression here, the denominator can never equal 0. So even if it says equal to 0, still never shade in the critical numbers from the denominator. But after that, now that we have it, now we can go ahead and write our final answer. So in interval notation, it's negative 14 to 2, and then 6 to infinity, or negative 14 less than or equal to x less than 2, or x is greater than 6. All right, one more example.